Hello, good morning dear friends. Here I am, Lalit Kumar P. BHAIYA, Associate Professor, Electronics and Telecommunication Engineering Department from this Bharati College of Engineering and Technology, Durg. Dear students, today we will learn about this analog electronics in unit number 3 multi-stage amplifier, the square wave testing, which is very important article in multi-stage amplifier. Now question is that why we need this square wave testing in multi-stage amplifier? Because in multi-stage amplifier, frequency response is very important. And when we go for the frequency response, we need to know the bandwidth also, magnitude and bandwidth, that is important. The phase response and magnitude response is important. And while doing so, we must know the three factors. One is called as the upper 3 dB frequency, that is one of the response factor of the multi-stage amplifier, cascaded amplifier, direct coupled amplifier, or any other types of amplifier. Another is the lower 3 dB frequency, that is also important factor. And third one is the rise time, which is shown here. These three terms are the very important terms in case of square wave testing in multi-stage amplifier or in amplifier also. So rise time, the upper 3 dB frequency and lower 3 dB frequency. Once we will see these three factors, upper 3 dB frequency, lower 3 dB frequency and rise time. Upper 3 dB frequency is given by Fh, lower 3 dB frequency is given by Fn, and rise time is given by Tr. We will see the definition and formulae for these three things, and later on we will go the effect of the frequency, effect of this factor on frequency response, effect of cascading on the frequency response in case of the multi-stage amplifier. Because after learning these three things, we will go for the effect of the cascading on this bandwidth, rise time, lower frequency, cutoff frequency and higher cutoff frequency, etc. Okay, now we will go first what I am doing here for testing the particular amplifier, cascade amplifier or amplifier. What we will do, we will apply this input signal that is supposed to be a square wave signal, and square wave is a continuation of the step signal, and hence I am using this square wave signal for testing purpose, applying to the amplifier, and I will see the output at this on the CRO, and from this output I will find the various factors. So what is happening, while calculating the upper 3 dB frequency, the amplifier will work the higher frequency circuit, that is this filter circuit supposed to be R2 and C2, like this. So this filter circuit will be worked. This is called as a low pass filter. Like a low frequency response will be obtained, and to get this upper 3 dB frequency we must know this. Let us assume that the amplifier works like say high frequency response circuit, sorry, not low frequency, high frequency response circuit. This is R2 C2, where Vi is this input and the amplitude of the input is V and output will be V naught. And the response is something like this. This is output, this is T, or you can consider the frequency maybe. So we will consider T here because we have to calculate the rise time. So we will go through the term T, and you will get this response over here. So this response, when I observe on the CRO, I will get the response in such a fashion. Then the time required to reach the 10% of the maximum value. Maximum value is supposed to be a V 100%. So 10% maximum value will require a time is called as T1. This T1 is the time where response reaches to the 10% of the maximum value, and T2 is the time where response reaches to the 90% of the maximum value. So this is 10% and this is 90%. So between these two, that is difference between these two, T2 minus T1 is called as the rise time. Rise time is the time required to reach the response from 10% to 90% of the maximum value. This is the definition of the rise time. So once again, what is rise time? Rise time is the time required to reach the response from 90% to 10% to 90% of the maximum value. So this is the time required to reach from this point to this point. This is called as the rise time. Here we calculate difference between these two is called as the rise time. So this is just like the charging of the capacitor in this circuit. So we will write the equation for this. V0 is equal to V into 1 minus e to the power minus t by R2C2. This is general charging equation of the capacitor. So this equation can be written as, and for 10% we will write V0 is equal to 0.1 times V. The maximum value is V. So we will write 10% is 0.1 times V. So 0.1 times V is equal to V into 1 minus e to the power, and this value is T1 here. The respective time is T1. So in place of this T we will write T1 upon R2C2. So we will get here T1 is equal to 0.1 R2C2. This is the time required to reach the response up to 10%. 0.1 R2C2. R2C2 are the components which are equivalent in case of the RC coupled amplifier or any other amplifier which behaves like this type of high pass circuit. Then for 90% value, again you change this value here. In place of 0.1 V, you can put 0.9 V, and this is equal to V into 1 minus e to the power minus, in place of t you put here T2 R2C2. So you will get T2 is equal to 2.3 R2C2. This is the 90% time required to reach the response at 90% is called as T2. T2 is equal to 2.3 R2C2. And finally, rise time TR is equal to T2 minus T1. So we will get here this rise time is 2.2 R2 into C2. This is the rise time in case of the amplifier, that can be calculated from 10% to 90% rise in the response. Okay, then once you get this rise time, you calculate this upper 3 dB frequency. Upper 3 dB frequency is given by fH, and this fH is equal to, this is called as cutoff frequency. Higher cutoff frequency is also upper 3 dB frequency, and this fH is equal to 1 upon 2 pi R2C2. Here fH is equal to in terms of rise time 2.2 R2C2. In place of this R2C2 you can put TR upon 2.2. So if you put here in place of R2C2 TR upon 2.2, you will get fH is equal to 0.35 upon TR. Is the formula for the higher 3 dB frequency or upper 3 dB frequency or higher cutoff frequency. So this is fH is equal to 1 upon 2 pi R2C2, or fH is in terms of rise time fH is equal to 0.35 upon TR. So this is the higher cutoff frequency. This is the rise time. This is the rise time. This is the higher cutoff frequency. Now calculate the lower cutoff frequency. For lower 3 dB frequency or lower cutoff frequency, this circuit, the amplifier will behave like this RC filter. This is called as the high pass filter. Right? You can calculate the lower cutoff frequency like this, and the response will be tilted. Here you will get the tiltation response. As the high pass filter is there, the response will be tilted here. This type of response we will get here. Let us say this tilted value is V dash at T1, and the maximum value is V here. Maximum value V, and where it is tilted at time T1, this value is V dash. Okay, then in this case one more factor you have to remember, that is percentage tilt is called as a P. this percentage tilt is given by V minus V dash upon V. V minus V dash upon V into 100 is called as percentage tilt, and it is represented by P in case of the square wave testing. So this P is also important factor here. Once you get this P, and the lower cutoff frequency from this circuit is given by 1 upon 2 pi R1C1. R1C1 are the components for calculating this frequency. So 1 upon 2 pi R1C1 is equal to lower cutoff frequency. And in terms of this percentage tilt P is equal to T upon twice R1C1. If you put T is equal to 1 by F, so 2F into R1C1, 1 upon 2F into R1C1. Or in terms of this 1 upon 2 pi R1C1, you can put FL. FL, you know FL is equal to 1 upon 2 pi R1C1. So in place of 1 upon 2 pi R1C1, you can put FL. So this is pi into FL by F into 100. So this is the P, that is percentage tilt in terms of this lower cutoff frequency and operating frequency, input frequency F. So this P is equal to pi into FL upon F into 100, and this lower cutoff frequency is 1 upon 2 pi R1C1. So dear students, these three important parameters, one is called as here I can say 4 parameters you have to remember as far as the square wave testing article is concerned. That is, one is the rise time, TR is equal to 2.2 R2C2. Another is the higher cutoff frequency, FH is equal to 1 upon 2 pi R2C2, or this 0.35 upon TR in terms of the rise time TR. Next one is the percentage tilt. This percentage tilt is given by V minus V dash upon V, and in terms of percentage tilt, we can write P is equal to T upon 2 twice R1C1, or it is equal to pi into FL by F into 100, and the lower cutoff frequency is 2 pi R1C1. So these three important parameters, 4 parameters you can say, should be remembered in case of the square wave testing of the cascaded amplifier or multi-stage amplifier. Later on, we will see the effect of cascading, on this bandwidth, and effect of cascading on bandwidth with respect to these factors, these basic factors in case for the square wave testing which are important. These factors may be considered for the effect of cascading on bandwidth, etc. Dear student, numerical may be asked on the basis of these formulas also, and many times it was asked, calculate the rise time required for so and so frequency given, and these are the values of the components. For the same, calculate the higher 3 dB frequency, calculate the lower 3 dB frequency, and finally calculate the bandwidth. So this should be calculated with the help of these formulas. In previous exam also, the very little question was asked to derive this formula. In similar fashion, you can derive the rise time, higher cutoff frequency and lower cutoff frequency. Right? So dear friends, dear students, next time we will go for the effect of cascading on bandwidth. Right? Thank you very much. Thank you for hearing.